right, 14.4, page 502 and 503. New concept. The prior three lessons have absolutely nothing to do with these last three lessons. So everything that we did, that quiz that we did, that's pretty much the end of algebra at this point here. We'll need to use some algebra to solve some of these things here, but not terribly complex here. So what we're introducing here, ultimately we're building up to this thing right here, which again, I have some different copies that I've made here. I can give you guys, you're not really going to need them much today, but the next two lessons, you're going to be working with here's our next lesson, the grid coordinate plane, being able to name coordinates, identify coordinates. Kind of like Battleship to an extent. I mean, there was always two coordinates you have to give, like a letter and then a number, right? Place your ships all over the place there, and you'd say A3. And then if you had a ship there on that A3 spot, that would be a hit. If you didn't, that would be a miss there, and you kind of run all around the grid trying to just rattle off different coordinates looking for it there. So this function's pretty similar to Battleship. I mean, there's no letters involved. These letters are just points here, but we'll cover this more next week here. But there's an X, a Y axis, so all these ordered pairs are defined by two different numbers here. The order that you state them matters a lot. Because again, there's a 2, 2 over here, or a 2, 3 over here. There's also 3, 2 right here. So 0.23 and 0.32 are totally different points. So, and that's where we're getting. Our last lesson there, we're going to do some graphing on here, graphing out different equations. So today, we're going to look at some of these equations. When you are working with graphing different types of equations, if you look at here, y equals x plus 4, y equals x minus 8, y equals negative 3x, y equals x divided by 2. Basically, those are equations, right? You're solving for a variable, you're solving for x, and then your answer is whatever y happens to be. So when you're dealing with function tables here, I don't know how much of this we need today, but a function, all right, I wrote somewhere else here. Come back to that sheet. There we go. So a function is an equation in, how do I want to say that? I'm going to put it this way. Y equals x, I'll say plus, minus, multiply, or divide by something. And x is considered your input value. X input value. And what that means is you have control. Okay. You have control over what your x value is. You can set that yourself. For at least 6th grade here, they will define what x is going to be for you. You can see if you look at these different rules and things here, you see the x value is already decided. If x is this, what is y, so to say. But when you're dealing with functions, your x value is your input. Every input can have exactly one output. We'll cover that more in the future here, but your x value is whatever you want it to be. Your y value is your output. And your output is basically the answer, what you're solving for. Because every equation here, I'll just write one out here. I'll say y equals x plus 4, right? So how do I solve this? Well, what I need to know, and you guys can pick a few different values yourself. Usually you use pretty small values when you're graphing. We'll cover that when we start graphing here, but you don't want real large numbers. I mean, look at my grid here. It basically goes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you want values that are small. I mean, if I have an x value of 17, well, that would be way out here somewhere, and you know, it's hard to graph those points that are way far away from each other here. You'll just use a lot of space here. So usually you use real small values. But if I said x equals -2, 0, and 2, okay? And then it has the rule here. It says the rule. The rule is whatever the equation is. I would. Right, because I know how to do all this. And then it says ordered pair. So looking very similar to what 1 and 2 look like right here. We see our x value, that's already defined for us. It says y, or the rule here. Sometimes it says the rule for there. We can just call this y, and then the ordered pair. So when we're dealing with functions, don't need that now. When we're dealing with functions, you need a function rule, which is essentially just an equation. This is the rule right here. Okay, that's my rule. So I set, or you will be able to set when you're working with any function here. And there's two real different types of functions out there. There's linear functions, and there's quadratic functions. We will explore linear functions here the next couple years. Quadratic functions I've never gotten to with the 8th grade, and it's not really something that you need to know too much in middle school. Quadratic functions are a little different. But a linear function, when you plot the solution, such as this here, you will get a straight line all the time. This would be and we cover that concept, a linear function. When you're doing linear functions and plot your points there and connect them together, you'll always form a straight line. Quadratic functions bend and curve around here. So linear functions is what we're really going to be talking about here. But here's my equation. Y equals x plus 4. So I have my 3 different x values. So if I plug -2 into this equation, what do I get for an answer? What's -2 plus 4? Positive 2. And then same thing. Here's another coordinate. The 0, again, same equation. If I plug that in, what's 0 plus 4? 4. And then one more time, third x value, x equals 2. What's 2 plus 4? 6. So there's my y values right there. My x values were -2, 0, and 2. My y values were 2, 4, and 6. You will always solve for your y value. That's your output. That's your output. Your x values are your input. You select the x values, normally. This year, they'll just be provided to you. But to solve any of these here, same thing with number 1. We see all these values for x right here. Right? So all I'm going to do is basically solve this equation 3 different times. It says y equals x plus 5. X is -6. So if I plug it in, -6 plus 5 is? -1. X is positive 12. If I plug that in, what's y?
Positive 17.
If x is 48, what's y? 53. So the rule never changes. Okay? The rule never changes. Every input has exactly one output. And again, we'll cover that another year, but this is really all there is to it. So they talk about ordered pairs here. Okay? And when we say an ordered pair, all right, this now gets to, if I put this on, like plotted this point on here, maybe I can do that here. So basically have 3 ordered pairs here. But when you're naming your ordered pairs, generally you always put them in brackets. You just do, it just is. So we can kind of look ahead here, see here's some other ordered pairs. Basically it's saying, what's the letter that's at -4, 3? What's the letter that's at 1, 2? What's the letter that's at 3, -5? Notice how they're all in brackets there. Ditto with this. Here's some more ordered pairs. You can see that they're in brackets here. More ordered pairs, more ordered pairs, and more ordered pairs. So ordered pairs are pretty much always written in this way. But there are 2 different things going on here. If you look at they don't really have a graph here, but your left and right, that's your x coordinate here, okay? And they have an x right there, you see it there. So this is your x coordinate here. Your up and down is what your y value is. But whenever you write ordered pairs out, the x value is always written first, separated by a comma, and then your y value is represented second. Always. Always is this way. Always. Because as I told you, there's 0.32. 0.32 is right here. And then there's 0.23. Well, 0.23 is over here. There's 3,2 right there. There's 2,3 right there. Those are 2 totally different points, right? So the order that you represent this information is really important, because every single number on here, there's a 1, -1, there's also a -1, 1 coordinate here. If you don't say it in the right order here, well, then you're referencing a whole different point. But if I wrote out the ordered pair for this first one here, basically I'll make my brackets. Whatever my x value is, in this case it was -2, I write that. A comma separates your x value from your y value, and then my y value was a +2. So then I just write a +2 right there. This is the ordered pair. This is a point I could plot on my graph. And again, we'll start plotting some points next week on Tuesday when I see you again here. But getting used to this here, how are these written and what do they represent? If I plug in this ordered pair back into the equation here, it makes the equation true. Where -2 plus a +4 does equal a +2. This is a solution to the equation. This is a solution here. If I wrote the ordered pair 1, 2, well, that wouldn't be a solution here. I mean, that is a point I could plot on the graph there. But if I plug this into the equation, if x is 1, 1 plus 4 does not equal 2. So this is not a solution to the equation here. I mean, I'm not saying it's not a point on the graph somewhere, because it is, but it's not a solution to our equation here. So for each of these here, we're trying to identify a couple of different things. We're trying to, one, your x values to be determined. You're trying to figure out what your y value is. You're solving for y. You're solving the equation. And then you're getting practice learning how to represent that solution in ordered pair form. And we're going to build you up here at the very end. Our final step, final lesson will be to basically start graphing our functions here. Where same thing we're seeing today. There's your x, there's your y, there's your rule, there's your ordered pair. But then you're going to have to graph it, similar to this here. We'll put all those points on the grid. If it is indeed a correct solution, all the points will make a straight line. If you have a point that is not part of your straight line, well, then you have an error somewhere in your solution here. So this is what we're going to end up with and where we're going with this here to start graphing these types of things out here. So what would be the ordered pair for this one right here?
0, 4.
Right, because my x value is 0. My y value, once I solve the equation right here, that provided me my y value here. of 4. And this one here, what's the ordered pair?
0. I mean, 2 and 6.
2 and 6, right. Sticks here so I can hear from lots of people today. Okay, so we kind of did number 1. Why don't you guys try number 2? Looking at page 502. So it says on top, the rule is y equals x minus 4. My x values are negative 12, positive 4, positive 73. I want to know what my y values are, and I want to know what the ordered pair is. So complete the table.
The best way to complete it is just to write it out, right? Probably. Yeah, write the whole graph out. Yeah.
I'd write it just like this here, but again, we always set x as your input. You determine the x value. And again, I could just leave it blank and you can make up any values you want for x. It doesn't matter. And going into next year, that's exactly what you'll do. You'll be responsible to set your own inputs yourself and then solve for the outputs. But you can control whatever the inputs are. Would I use these values normally? I would not. Because do I want to try and graph a 73 on here? Well, I don't even think there's 73 spaces, to be honest with you. So I don't even think I could graph that on this piece of paper. And again, we'll practice this a lot more in the future. Okay, we all got it? All right, so first up, x is negative 12. What's my y value? Sig.
Negative 8, right?
Nope.
Negative 16.
Negative 16. Negative 12 plus a negative 4. Rewrite as an addition problem. This is the same as that. And now I can use that because I can tell the signs are the same. Add the values here. Negative 16. What's my ordered pair?
Negative 12 and then negative.
Right. So I'm using my brackets, listing my x value first. A comma separates the x from the y value. Negative 16 second. Close the set. This is how you should always write your ordered pairs out here. Always. All right. X is 4. What's y? Brooke.
So x is 4 and then the y is 0.
Yep. My ordered pair?
4, 0.
4, 0. Just like that. Again, if you're putting the little plus signs on here, all the power to you. I don't care. All right. X is 73. What's y? Savannah.
77.
73 minus 4.
69.
69. What's my ordered pair? What's my x value?
Negative 7.
X value is right here. There's my x, there's my y. So what's my x value? 73, so I write that first, and then a comma. And then what's my y value?
69.
69, right. Same thing as my solution here. So basically your answer is always what your y value is. Whatever your answer is, that's your y value, which is your output. You put something into the equation, da-da-da-da-da, beep, 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 beep. Something comes out the other side then, right? And you put something in, equation runs, boom, here's your answer on the other side. That's your output. That's what comes out after the equation's done here. Okay. Use the function table to complete the function table. So this time they change it up, D equals 5R. Why they do it that way, I don't know. So I'm going to rewrite, I don't even like 7 and 8 to be honest with you. Do they ask you anything in that form? They do not. So they present, your first 4 problems are similar to 3, 4, 5, and 6. So let's set that up here. It says the function rule 'cause this is what your first four problems are gonna look like. And then your ordered pairs. So this will take a little setup here, 3, 4, 5, and 6. And I know the function rule, y equals x plus 4. And then I have 4 ordered pairs here, negative 11, and then it says y. Then I got 0, y. Then I got 6, y. Then I got 9, y. All right, see that? So basically what I'm doing here is I'm trying to figure out what my y value is. They present the ordered pair. What is this number right here? What's this negative 11?
It's X. It's X.
That's my x value, because remember, these are ordered pairs. Ordered pairs always are in xy form. So all of these first numbers here are my x values. It's very similar to what we did. But now that I know what x is negative 11. Now I go back to the equation here and plug that in. Negative 11 plus 4 gives me a, so I'll just write it beneath like this here. And you're just solving for y in these right now, but they're showing it to you in a different form. They're showing your input in a different way this time, right? So this one here, I see a 0, and I know that 0 is my x value. So I plug it back into the equation. 0 plus 4, y is 4. Agreed?
Agreed.
6. Plug it back in. 6 plus 4, y is 10. 9. Back in I go. 9 plus 4, y must be 13. See how we did that?
Yep.
So you still have your x value because these are x1. You know all your x's. It's the same thing we just did, except they're giving you your x value in a different way this time. They're showing it to you as part of the ordered pair. So you guys try number 4. Y equals x minus 8. Yep. Yep, I'll give you a moment here. And again, it's not by accident that you're always solving for y, because y is always your output value. You control what x is. And when you get to higher level stuff here, you can finagle that around a little bit here. And I'll show you how that can work in 8th grade. But for now, it's best just to stick with this here. Because you don't need to know all these exceptions to the rules today. So basically I'm looking for 4 solutions here. That's what I want. I want 4 solutions. Alright. So I'm looking for 4 numbers. I'm looking for 4 different y's here. You don't have to rattle off the entire ordered pair to me. I get it. But I do want what the... There we go. Alright, so fill me in here. What am I missing? What's the 4 values left to right? Damien.
Negative 20 and negative 12 is the first pair.
Nope.
No?
Whenever I see x minus 8, again, that's the same thing as plus a negative 8. So try again.
So negative 20 and negative 28.
The other way around.
Or negative 28 and
Right. Negative 20, negative 28, negative 12, negative 20. Next one. 8, what?
8, 0 and 0.
8, 0, 35,
43.
No.
43 and 30.
35 minus 8,
Oh. 27.
27. Good.
So it's the biggest number is always first.
No.
Wait, then.
No.
In this
X
case, it
is
was
always
based
first.
on the equation. Like I go back to the first one, the smaller number was first. See? Smaller, bigger, smaller, bigger, smaller, bigger.
X is
Yeah.
always first.
There are patterns in these here. I mean, you can probably see that in this case here, the y value is always 4 greater than the x. But that's because that's what the rule says. In this case here, every y value is just 8 less than the x. Because why? Because that's the rule. That's the rule that you're applying here in this one. Number 5, y equals negative 3x.
Oh, we got tiny little cells.
So same deal, right? This is a multiplying one here this time.
We know that.
So same deal. Solve the equation 4 times. And then I'm looking for those 4 solutions.
So high. Whoa, dang. Whoa. Kind of weird. It's kind of true. Oh, Miss Slangus, journal was what was something that made you laugh this past week? I did Asian roasted sig a lot.
All right, you ready?
I actually did
No, I'm not.
I'm not really.
Okay, well, I see some people just talking away.
I'm not talking at all, but it's
Okay.
distracting women.
Well, then if you're talking, let people get their work done.
Okay.
So everybody can solve this here. Um, 5 through 14 are pretty much the same thing we did in here. They give you a rule, they just give you 2 different equations with 5 different x values to plug in. So you're solving for y, then you're writing out the ordered pair. The last one here, complete the function table. You need to figure out on your own what the rule is. How did I get from x to y? They give you x and y coordinates a couple times, but what's the rule? How did I get from x to y? What is this part right here? What's this? What's this? What's this? It's not hard to figure out here, but in your homework, you need to identify what the rule is in play. And you should write it out in y equals x form. Similar to this. Y is going to equal what? X plus, x minus, x times, or x divided. So this will be our last problem. We do number 6 then. So, okay, 5. Fill me in. What are my missing values? Sierra.
And so 10 and negative 30.
Yep.
And then it would be 0 and 0.
Yep.
And then 3 and 9.
Negative 3, positive 9.
And then it's negative 15 and 45.
Very good. Right. So, perfect. Yep. Make sure these are positive values over here. The 9 and 45 are positive because I'm multiplying a negative times a negative. Converts it to a positive. All right. Last one. Y equals x divided by 2. Negative 40y, negative 26y, negative 14y, 0y. Right. So last one, and then we'll do some deer time.
Okay. I
What
barely
is
have
y?
any notes. Yeah.
Took
Are
a-
you not writing it down?
I have this much. This is 1414. This is 1413. 13. Those are so small.
This is 14.4.
Yeah.
What? This is I have this.
14.4.
All right, we all got it? Well, what are we doing here?
Things are easy while we're getting chicken, so I come over and listen.
So on Tuesday, name of the game will be if we had to graph all this, how do we do it? Where do they go? How do we know what's what? What are the different areas of the grid coordinate plane? There's 6 different areas, by the way. So we'll cover all them. How do we know what lies in what area? So on and so forth. All right. So what are my missing values? Evangeline.
Negative 40 and negative 20.
Yep.
And then, negative 26 and negative 12, or negative 13,
Negative 13.
negative 14 and negative 7,
Good.
and then 0 and 2, negative 2,
0 divided by 2?
oh, 0.
Right, anything divided by 0 is 0. 0 divided by anything there is 0. So, all right. Questions? Again, getting used to functions, getting used to ordered pairs, understanding that X is an input, Y is an output. I think you guys generally get it here. We'll review, we'll practice this again the next couple lessons and how this all works here. But function, main objective on Tuesday, get used to the grid coordinate plane. How do we plot all this stuff? And then our last lesson will combine these 2 lessons together. Where not only will we identify this stuff, but we will be able to plot and graph. So we'll combine both the first 2 lessons together for the 3rd lesson here. Yep.
Like and subscribe, please.